Bismillahirrahmanirrahim. Today I'd like to talk about sequences and series. A sequence basically is a list of numbers written out like this. For example, I have this sequence of numbers 2, 4, 6, 8, 10, and like that. And that's of course a list of even numbers starting with 2. And then if I were to take the same numbers and if I were to add them together like this, 2 plus 4 plus 6 plus 8 plus 10, like that, and the pattern would continue, that would be a series. So a sequence is where you're just listing numbers like this, and a series would be where you're just adding these numbers like that. Now that's the first thing that we have to appreciate. Now you can't get these two words or these two terms confused. I don't know, you can remember the sequence as a Q, like a curly type of thing, has commas in it. And the series, I don't know how you can remember, but a series, the R kind of looks like a plus sign like that. So R, if you use your imagination, looks like when they're being added up. And a sequence, if you use it for like curly Q like this, kind of looks like commas like that. So you can't confuse these two very similar sounding words or similar looking words. A sequence therefore is a list of numbers written out like this, and a series is a list of numbers added as is shown over here. Now another important concept here in the beginning that we have to appreciate is that sequences and series, they can be both finite and infinite. The examples that I have given you over here are infinite. So this is an infinite sequence, and this is an example of an infinite series. That means it keeps going. That's why you have these three dots or ellipses over there. So sequences, however, and series, they can be finite. In other words, they can have a limited number of terms. Here's an example. I have 1, 3, 5, and 7, and that's the end of that. And this series over here, I'm going to have 3 plus 5 plus 7 plus 9 plus 11. So, and that's the end of that series. So this particular series over here that I have written is a finite series, and this particular sequence that I have written over here is a finite sequence. So, and because it has a limited number of terms. In this case, I have 4 terms over here, and over here I have 5 terms like this. Now, as you can see over here, these are reasonably easy sequences and series to understand. They have a particular pattern. The pattern, they may be discernible. They may not have any pattern or any pattern that you are able to understand. So sequences and series may have a certain pattern or rule that they seem to be following, or they may have rules that are very difficult to appreciate, or they may have no rules. But anyway, the first important concept for us to understand is the concept of basic definitions of sequences and series. A sequence is a list of numbers, whereas a series is a list of numbers that are added together. Sequences and series can be finite, and sequences and series can be infinite. That means they have infinite number of elements, or finite number of elements in the case of finite sequences and series. Each of this single number, each of this number is called either an element or a term. Okay, so you can give it different names. This is either a term or it's called an element. And frequently, of course, you need to give them names. This is the first term, and this would be the second term, and this would be the third term, etc., and to continuing that way. Now, in case of a infinite series, this would be the first term, of course, and the second term, third term, fourth, and then you might have like 100 term. And if you wanted to give it a generic name, you can say the generic term is like the nth term, the 10th term, the 100th term, the 2000 term, etc. So this is the first basic appreciation of sequence and series, that there are finite and infinite types of sequence and series. Sequences are just numbers that are listed, and series are numbers that are added together. Now, there are other terminology that we have to appreciate. the first terms is typically expressed as a sub 1. Now you can use any alphabet to express these things, but typically A is popular when talking about sequences and series. So the first term is given this particular name, A sub 1. Sometimes, depending on the circumstances, it's labeled as A sub 0. So the first term could be starting out with A sub 1. It's the first term, which is natural and seems that's to be most of the case, but sometimes it's more convenient and it's helpful to label the first term A sub 0. As I suggested, you could use any alphabet. You could use P, Q, R, L, whatever, but A is a popular alphabet when talking about sequences and series. And the second term, therefore, is labeled as A sub 2. That's A sub 2. And the third term is A sub 3. And if this is an infinite series, there will come a time when you have exhausted, you'll have like A sub like 51, and you keep going. And the generic term will be labeled as A sub n. Same thing with the series also. So you have this first term is A sub 1, the second term is A sub 2, and the third term is A sub 3, and then we'll keep going like this, and then you get to a generic term, some term. Now you can call it A sub n. Now, if you wanted to talk about the terms that are before and after this particular generic term, you could call the next term, for example, A sub n plus 1. That is, if this was the 50th term, the next term, of course, would be 51, A sub 51. And if you wanted to talk about this term that precedes it, you can call that term A sub n minus 1. Correct? So, a generic term or a hypothetical term that you are talking about, but when speaking of sequence and series, you labeled it as A sub n, and in case of a series, the following term would be A sub n plus 1, and the preceding term would be A sub n minus 1. And in fact, you could keep going like this. In reference to this, the term that comes 2 terms afterwards would be A sub n plus 2. And the term that's 2 spots removed this way would be A sub n minus 2, like this. But that's getting a little bit more than what usually we would have to appreciate. So anyway, the generic term is A sub n, and the term before and after are designated sometimes using that generic term. Now, in describing sequence and series, now you can see when we're talking about sequence and series, it becomes kind of redundant, like sequence and series and sequence and series. It ends up being that we talk mostly of series, because if you understand, sequences is just a collection of numbers that are stacked next to each other to kind of look pretty. But what are you going to do with the sequence? But it's series, you're doing a mathematical operation there. You're adding them. You can subtract them, this and that. So it ends up being that we talk more about series than we talk about sequences. But most of the time, when we speak about sequences and series, conceptually, many of the concepts apply to both of them. Nevertheless, so these terms are frequently used together. So when we describe sequences and series, there are many ways of doing this, but 3 ways of describing a particular sequence and series are as follows. 1, you can just list the terms. Okay? So, like I have done over here, I describe this particular series and a particular sequence by just listing the first few terms, right? These are both infinite series, so I listed here the first 5 terms, and it is understood that the reader is able to extrapolate the remainder of the terms based on the first 5 terms. So, and this is also especially useful if the terms, if it's a finite sequence or a finite series. You just list all the terms up, and if it's an infinite series, you put ... Assume that the reader is able to derive the remainder of the terms based on the pattern that you have demonstrated. Another way of describing a sequence as a series is to give a rule. So you can describe a sequence in a series by just listing the terms, or you can describe a sequence in series by giving rules. By giving rules, we mean the following. You can give a rule, a mathematical formula that says this is how you get the nth term. Okay, in terms of describing sequence as a series, there are two types of rules that can be used. The first type of rules is called a recursive rule. Let me use a different color over here, maybe. All right, so a recursive rule and the second type of rule is called an explicit rule. Now, a recursive rule is a rule that allows you to get a particular term based on the term before. For example, a recursive rule allows you to get a sub nth term based on a sub n minus 1. For example, in this particular case that we have over here, you'll see clearly that what you're doing over here is you're adding 2 to each term. So you take 6 and you add 2, you get 8, and then you add 2 to that, you get 10. So the next term can be generated simply by adding another 2. So the recursive rule for this particular sequence would be as follows. To get any particular nth term, you take the term that preceded it, a sub n minus 1, and simply you added 2 to this. Correct? So this is an example of a recursive rule. That is, you describe a sub nth term based on the a sub n minus 1. The reason it's called recursive, the term recursive is like the recourse, is to fall back to. So you fall back to the last term to generate the next term. But you see, this will give you the rule. But the rule will be not very helpful unless you know what the first term is. So when you're describing a sequence as a series, using the recursive rule, you have to give the rule, but you also have to give what the first term is. So you have to say a sub 1, the first term, is 2. So using this is a description that you can derive the entire sequence or a series by these two facts. So I know the first term is 2, and I get the subsequent terms by adding 2 to this. Okay, so for example, I'll give you an example of a sequence and a series based on the recursive rule. I say the first term I'm going to decide it's going to be a sub 1 is 5. I'm just saying the first term is 5, and then my rule is I get the next term I get a sub n by multiplying the term before it, a sub n minus 1 by 2. So, well, that's good. Well, I take a sub 1 is 5 if I'm creating this particular sequence. The next term would be, I just have to take this term and multiply it by 2. So you take a sub 1 to get a sub 2. I said a sub 1 and multiply by 2, I get 10. And then the next term, I have to take this term and multiply by 2, I get a 20. And then after 20 I'll get a 40, and after 40 I'll get an 80, and this will continue. As you can see, I'm using the rule to generate each term. I multiply this by 2, and I multiply this by 2, and I multiplied this by 2, and I multiplied this by 2. Okay, now this is an example of a sequence that was generated not by first just writing out or listing the terms, but by giving two pieces of information. One, the first term, and secondly, a recursive rule. In other words, a rule that allows me to get a sub n based on the term that was before. But then you can see the limitations of this particular method. What if I wanted to know what a sub 55 was? Well, that's going to be very difficult, because to get to 55, I would have to generate the term that was before this, and then have to generate the term that was before that, generate the term before that, all the way starting from the very beginning. And that could be very, very cumbersome. Well, in that scenario then, the explicit rule is very helpful. The explicit rule allows you to generate a sub n, any particular n, based on simply the first term, like this. Okay, so let me give you an example. I say I have in my mind a particular, let's call it series in this instance, where a sub 1 is 2, and to get to the a sub n, what I'm going to do is I'm going to take 2 and take do this 2, and I'm going to multiply like this. Okay, well, this is the rule, which is fascinating, but look at this rule for a minute. Okay, now here, this is I'm given the first term. Cool, I like that. I'm given the first term, and I'm given a rule for getting a sub n, just like before. See, here I was given a rule for a sub n also. So both the recursive rule and the explicit rule tell you how to get a sub n. But the difference is this: in the recursive rule, the a sub n is derived based on a sub n minus 1, the term before it. But in the explicit rule, look what happens. Okay, the rule is this, in fact. A sub n in this case is a sub 1 plus 2 times n minus 1. Okay, in the explicit rule, I'm given a rule for a sub n, which is based on the first term, a sub 1, and n itself. So if I wanted to get, let's say, okay, I'm just going to generate the first few terms. Okay, the first term I'm given is a sub 1 is 2, right? And I said this was going to be a series. I'm going to add. The second term is a sub 2 is going to be the first term, which is 2, plus 2 times n. N is 2 in this case. 2 minus 1. N is the number of term, the second term. So 2 minus 1 is just 1. So 2 times 1 is 2. 2 plus 2 is 4. And then I can get the third term, not based on the second term, but based on the first term. The first term was 2. And then 2 times the quantity n. In this case, n is 3. So 3 minus 1. So 3 minus 1 is 2. 2 times 2 is 4. 4 plus 2 is 6. And then a sub 4, again, is based on a sub 1. And I'm told a sub 1 is 2. Plus 2 times the quantity n. And again, n here is 4 because I'm trying to find the fourth term. 4 minus 1. 4 minus 1 is 3. 3 times 2 is 6. And that's 8. So I can write the first few terms over here. And it would be like this. 2 plus 4. And then there's this plus 6 plus 8. And like this. I can keep going, can't I? Now that's basically the sequence that I had written in the beginning over here, like over here. And I start out by just listing the terms, correct? And here I'm giving a particular explicit rule, correct? To just get any term. Now you can see the power of an explicit rule, because explicit rule will allow you to do the following. Say, I can say, okay, I want to know what the a sub 51 is. Well, a sub 51 is going to be a sub 1. The first term is still 2, correct? Plus, the rule is this: 2 times the quantity 51 minus 1. Okay, that's 2 plus 2 times the quantity 51 minus 1 is 50. 50 times 2 is 100, and that's going to be 102. Okay, so that's the beauty of this. So in summary, I like to summarize here before we finish. And today we introduced ourselves to the concept of sequence and series. Sequences are just a list of numbers. Series are when they're added together. Terms are labeled as follows: a sub 1, a sub 2, and a generic term is a sub n, and the term before is a sub n minus 1, and the term following is going to be a sub n plus 1. There are 3 ways of describing sequence and series for somebody. The first is by just listing the terms. The second is by describing the sequence or series by giving what's called a recursive rule. Recursive rule, as in to rely upon, to fall back onto. The recourse is to describe the nth term, a sub n, based on the term that's before it. So a recursive rule is to describe the nth term based on the term that's before it, and you would still have to know what the first term is. And the explicit rule is another way of describing sequence and series, where you're given, for example, a sub 1, but the a sub nth term is described or given by a rule, not based on the term before, but based on the first term and whichever term that you're working on. So this is the introduction to sequence and series. Inshallah, next time we shall continue from here. Until then, as-salatu was-salamu ala rasulillah, walhamdulillahi rabbil alameen. Assalamu alaikum.